Picture this: a vast, open night sky, unpolluted by city lights, where every star burns bright enough to cast faint shadows on the ground. This wasn't just a poetic scene for ancient civilizations. It was their lifeline. Long before compasses or GPS, humanity relied on the heavens to navigate the unknown, charting courses across treacherous seas and endless deserts, using nothing but the stars above. But here's the astonishing part. The star maps they created weren't just practical tools. They were intricate works of art, science, and spirituality, woven together in ways we're only beginning to understand. What if I told you that some of these ancient celestial charts hold secrets even our modern technology struggles to decode? Think about the Polynesians, who crossed thousands of miles of open ocean with nothing but the stars, waves, and their own intuition to guide them. Or the Babylonians, who meticulously recorded planetary movements on clay tablets, creating the earliest known astronomical records. These weren't just random observations, they were the blueprints of entire civilizations. The stars told them when to plant crops, when to set sail, and even when to celebrate sacred festivals. But hidden within these star maps are clues to something deeper, a forgotten language of the cosmos, one that connected humanity to the universe in a way we've since lost. How did they do it, and what can their ancient wisdom teach us today? That's exactly what we're about to uncover. This journey will take us from the shores of remote Pacific islands to the dusty ruins of Mesopotamian temples, piecing together the incredible story of celestial navigation. We'll explore the tools they used, from simple sticks casting shadows to elaborate stone observatories aligned with the solstices, and reveal why their knowledge still echoes in our modern world. Because here's the truth, these star maps weren't just about finding direction, they were about finding meaning. So, if you've ever looked up at the night sky and felt that tug of wonder, you're about to discover where that feeling truly comes from. The ancients left us a map not just to the stars, but to understanding our own place among them. Let's begin. The story of celestial navigation begins with a simple yet profound truth. For ancient civilizations, the night sky wasn't just a spectacle, it was a roadmap. Take the Polynesians, for example. These master navigators didn't just glance at the stars, they lived by them. Without compasses or written charts, they memorized the rising and setting positions of hundreds of stars, using them like celestial signposts to guide their double-hulled canoes across the Pacific. Imagine setting sail from Tahiti to Hawaii, a journey of over 2,000 miles with nothing but the stars to steer by. They didn't just survive these voyages, they thrived, discovering remote islands scattered like pebbles across the ocean. Their secret, a mental map of the heavens so precise, they could detect subtle shifts in star paths caused by ocean currents, almost like reading the wrinkles on water. Meanwhile, halfway across the world, the Babylonians were approaching the stars with a different kind of precision. Their astronomers, perched atop ziggurats, tracked the movements of planets and stars with an obsession that bordered on reverence. They etched their observations into clay tablets, creating the earliest known star catalogues. These weren't just random notes, they were mathematical records, predicting lunar eclipses and planetary alignments with startling accuracy. One tablet, dating back to around 700 BCE, even details the path of Venus across the sky, proof that their understanding of celestial mechanics was centuries ahead of its time. But here's what's truly fascinating. These two cultures, separated by vast oceans and entirely different worldviews, arrived at the same conclusion. The stars were more than just lights in the sky, they were a language. For the Polynesians, that language was sung in chants, passed down through generations like living maps. For the Babylonians, it was written in cuneiform, a permanent record of the cosmos's rhythms. Both systems, though wildly different in form, shared a single purpose: to turn the chaos of the night sky into order, a way to navigate not just the physical world but the passage of time itself. And then there's the mystery of how they did it without modern tools. The Polynesians used their hands to measure star angles, stretching their fingers against the horizon to calculate latitude. The Babylonians invented the astrolabe, a device so ingenious it remained the gold standard for navigation well into the Middle Ages. These weren't just tricks or lucky guesses, they were the results of lifetimes of observation, a dialogue between humans and the heavens that spanned generations. So why does this matter today? Because buried in these ancient techniques is a reminder: the universe speaks to those who learn to listen. In an age where we rely on satellites to tell us where we are, there's something humbling about realizing that our ancestors crossed oceans and mapped the skies with nothing but patience, curiosity, and the unwavering belief that the stars had stories to tell. Their legacy isn't just in the charts they left behind, it's in the enduring truth that sometimes the oldest ways of seeing the world are the ones that reveal the most. Consider the astrolabe, a device so elegant in its design that it's often called the smartphone of the ancient world. Crafted from brass or wood, this intricate instrument could measure the angle of a star above the horizon with astonishing precision. Developed by the Greeks around 150 BCE and later refined by Islamic scholars like al-Biruni in the 10th century, the astrolabe wasn't just a tool, it was a portable cosmos. Its rotating discs, etched with constellations and celestial coordinates, allowed navigators and astronomers to calculate time, predict sunrise, and even determine the direction of Mecca. What's remarkable isn't just its accuracy, but its versatility. A single astrolabe could serve as a calendar, a compass, and a star map, all folded into one handheld masterpiece. Now shift your gaze to the Pacific, where Polynesian navigators relied on something far more organic yet equally sophisticated: stick charts. These weren't charts in the traditional sense, but intricate frameworks woven from palm ribs and cowrie shells. The ribs represented ocean swells, while the shells marked key islands or star positions. To the untrained eye, they looked like abstract art, but to a master navigator, they were a three-dimensional blueprint of the sea. The real genius lay in their adaptability. Unlike paper maps, stick charts could be adjusted to reflect shifting currents or new discoveries, embodying a living knowledge passed down through generations. Then there's the humble gnomon, a simple stick planted in the ground that became one of humanity's earliest scientific instruments. By tracking the shadow it cast, ancient Egyptians could measure the sun's height, dividing the day into hours and even marking the solstices. The Chinese took this further, building elaborate sundials that accounted for seasonal changes in the sun's path. These tools reveal something profound. The ancients didn't just observe the heavens, they conversed with them, turning shadows and sunlight into a language of time and space. What ties these inventions together isn't just their functionality, but their artistry. An astrolabe wasn't merely a calculator. It was often engraved with poetic inscriptions or zodiac symbols, blurring the line between science and spirituality. Polynesian stick charts doubled as cultural artifacts, their designs echoing creation myths. Even the gnomon, in its simplicity, was often placed at the heart of temples, linking the mundane act of measuring time to the divine rhythm of the cosmos. This challenges a modern assumption that ancient technology was primitive. In reality, these tools were feats of engineering and imagination, born from centuries of patient observation. They remind us that innovation isn't just about complexity, it's about understanding the world deeply enough to work with its patterns. When a Polynesian navigator felt the tug of a current or a Babylonian astronomer predicted an eclipse, they weren't just using tools. They were thinking like the universe itself, and that's a kind of wisdom no gadget can replicate. To the ancient Egyptians, the night sky wasn't just a map, it was a mirror of their world. The three stars of Orion's belt didn't merely guide travelers. They were the celestial embodiment of Osiris, the god of resurrection. When they aligned the Great Pyramid's air shafts with these stars, they weren't just engineering a tomb, they were building a staircase for the pharaoh's soul to ascend to the heavens. This wasn't astronomy as we know it today. It was cosmology, theology, and architecture woven into one. The pyramids didn't just point to the stars, they whispered to them, a dialogue between earth and sky that shaped an entire civilization's understanding of life, death, and eternity. Halfway across the world, the Chinese gazed at the same stars but saw something entirely different to them. The heavens were a vast imperial court, with constellations acting as celestial bureaucrats. The North Star wasn't just a navigational anchor. It was the purple forbidden enclosure, home of the Jade Emperor, ruler of the cosmos. Stars that flickered or strayed weren't just astronomical phenomena. They were omens, signs of divine displeasure that could send royal astrologers scrambling to interpret their meaning. The Chinese star maps, meticulously painted on silk or carved into temple ceilings, weren't charts. They were organizational diagrams of the universe itself, a cosmic government where every star had a rank and a role. Then there are the Lakota people of North America, who saw the Milky Way not as a scattering of stars but as the Wanogi Thachanku, the spirit road, a path where souls traveled to the afterlife. To the Maori of New Zealand, the Pleiades cluster marked the beginning of their new year, their appearance signaling the time to plant crops. These weren't just practical observations. They were threads in a tapestry of stories that explained everything from the changing seasons to the origins of humanity itself. What's striking isn't just the diversity of these interpretations, but what they share. Whether carved into pyramid stones, painted on silk, or sung around campfires, these star maps all served the same profound purpose. They transformed the chaos of the night sky into order, meaning, and belonging. The stars weren't just lights to navigate by, they were ancestors, gods, and teachers. They were the keepers of time, the architects of destiny, the bridge between the mundane and the divine. This changes how we think about ancient astronomy. It wasn't just about predicting seasons or plotting courses. It was about answering the biggest questions humans have ever asked. Who are we? Why are we here? The answers weren't found in textbooks or equations. They were written in the stars, in patterns so enduring they outlasted empires. When we look at these ancient maps today, we're not just seeing coordinates. We're seeing the fingerprints of countless generations who looked up and dared to dream the sky into story. And that's a legacy no modern telescope can ever replace. The Polynesian Wayfinders didn't just navigate by the stars, they danced with them. Imagine standing on the deck of a double-hulled canoe, the vast Pacific stretching endlessly in every direction with no landmarks in sight. For most of us, this would be a nightmare of disorientation, but for these master navigators, it was home. They didn't just memorize star positions, they internalized them, knowing that each star rose and set at the same point on the horizon night after night, year after year. They called these star paths kavenga, a mental web of celestial highways that guided them across thousands of miles. But here's what's even more astonishing. Stars were only part of the story. The Polynesians read the ocean like a living text. They observed how waves refracted around islands, creating subtle patterns in the swells. They watched the flight paths of birds, like the golden plover, which always returns to land at dusk, to estimate distances to unseen shores. Even clouds betrayed secrets. Stationary puffs on the horizon often signaled land beneath them, their bases tinted green by reflected vegetation. This wasn't just navigation. It was a symphony of observation where every element of nature played a note. And then there's the human element. Wayfinding knowledge wasn't written down. It was passed orally through chants and apprenticeships that could last decades. A master navigator, or PWO, didn't just teach star positions. They cultivated an almost supernatural awareness. They could feel currents shift beneath the hull, taste changes in the wind, and sense land long before it appeared. This wisdom was so sacred that navigators often blindfolded apprentices during training, forcing them to rely on instinct and memory alone. Colonization nearly erased these traditions. By the mid-20th century, only a handful of elders retained the full knowledge. Then came the Renaissance. In 1976, the Hokulea, a replica of an ancient Polynesian voyaging canoe, sailed from Hawaii to Tahiti using only traditional methods, no compass, no sextant, just the stars. The voyage proved what skeptics had dismissed as myth, that Polynesians intentionally settled the Pacific's most remote islands, from New Zealand to Easter Island, through skill, not accident. Today, schools across the Pacific teach wayfinding to a new generation, rekindling a bond with the sea and sky that modern technology had almost severed. What makes their legacy timeless isn't just their accuracy, it's their philosophy. The Polynesians didn't conquer the ocean, they conversed with it. They saw themselves not as separate from nature, but as part of its rhythm. In an age where we trust satellites more than our own senses, their story whispers a challenge: to look up, to listen, and to remember that the oldest maps aren't on screens. They're written in the stars, the waves, and the wind. The Babylonians didn't just watch the stars, they measured them with the precision of accountants balancing a ledger. Picture a scribe in the temple of Marduk, crouched under the night sky, pressing a reed stylus into wet clay as Jupiter glides past a fixed star. This wasn't poetry, it was data collection. By 1800 BCE, these astronomers had already compiled detailed records of Venus's movements, noting its disappearances and reappearances with such accuracy that modern scientists still reference their work. Their tablets, baked hard under the Mesopotamian sun, became the first known star catalogues, not just lists of lights, but a mathematical language describing the rhythm of the cosmos. What set the Babylonians apart was their obsession with patterns. They noticed that certain stars returned to the same position every 365 days, dividing the sky into 12 equal slices, the birth of the zodiac. But this wasn't about horoscopes as we know them today. These divisions were practical tools. When the constellation Aries rose at dawn, farmers knew to plant barley. When Scorpius dominated the sky, kings consulted priests for omens before waging war. The stars weren't just guides, they were collaborators in the business of survival. Their greatest breakthrough, predicting eclipses. By meticulously tracking lunar cycles over centuries, they discovered the Saros cycle, a repeating 18-year pattern of solar and lunar eclipses. Imagine the power this knowledge held. When a Babylonian astronomer stood before a king and announced, "The moon will devour the sun on the 10th of Nisan," it wasn't magic. It was mathematics so advanced that it would take Europe another 2,000 years to match it. Yet their legacy extends beyond calculations. The Babylonian system of dividing circles into 360 degrees. Still used in your GPS today, their belief that celestial events influenced earthly affairs, the foundation of judicial astrology, which shaped medieval medicine and Renaissance politics. Even their mistakes were profound. They believed Mercury was two separate stars, one appearing at dawn, another at dusk, a misconception that later helped Greeks like Hipparchus unravel planetary motion. What's most striking is how democratic their astronomy was. Unlike the pyramid builders or Chinese imperial astrologers, Babylonian stargazers worked for everyone. Their almanacs told merchants when to expect seasonal winds, warned sailors of stormy seasons, and even guided city planners in aligning streets with solstice sunrises. In a world where knowledge was often hoarded by elites, their star charts were a shared compass, uniting farmers, kings, and poets under the same sky. That's the real genius of Babylonian astronomy. They didn't just map stars, they mapped time itself, turning the chaos of the heavens into a calendar, a clock, and a covenant between humanity and the universe. Their clay tablets, cracked by millennia, still whisper a radical idea that the cosmos isn't beyond understanding. It's a puzzle waiting to be solved, one observation at a time. While the Babylonians were crunching numbers on clay tablets, the Greeks were asking questions that would change astronomy forever. They didn't just chart the stars, they demanded to know why they moved. Take Hipparchus working on the island of Rhodes around 150 BCE. While others saw the night sky as fixed and eternal, he noticed something unsettling. The stars weren't quite where they should be. Comparing his own observations to records from a century earlier, he realized the entire celestial sphere was slowly shifting. This wobble, now called the precession of the equinoxes, proved the heavens weren't static. They had a rhythm, a slow dance that took 26,000 years to complete. Imagine the audacity of that discovery, realizing the sky itself was in motion, centuries before telescopes even existed. Then there's Ptolemy, whose work, Almagest, became the astronomical Bible for over a millennium. His star catalogue didn't just list positions, it predicted them, using geometric models to explain planetary loops that had baffled observers for generations. Sure, we now know his Earth-centered system was wrong, but the precision of his math was staggering. His calculations could pinpoint a planet's position within 2 degrees, a feat akin to hitting a bullseye blindfolded. What made Ptolemy revolutionary wasn't just his accuracy, but his approach. He treated the cosmos as a puzzle to be solved, not a mystery to be worshipped. The Greeks' real masterpiece, though, was the armillary sphere. Picture a series of brass rings nested like a skeletal globe, each representing a celestial circle, the equator, the ecliptic, even the horizon. Turn the central axis and you could simulate the night sky for any date or latitude. This wasn't just a model, it was a thinking machine, a tangible proof that the heavens operated by rules humans could grasp. Scholars from Alexandria to Baghdad would spend centuries refining its design, using it to teach everything from basic navigation to the nature of cosmic harmony. What set the Greeks apart was their willingness to challenge myths with math. Where the Egyptians saw Orion as a god, the Greeks measured his belt's angular distance. Where the Chinese read omens in comets, Greek philosophers like Anaxagoras argued they were natural phenomena, a claim so radical it got him exiled. This shift from storytelling to system building didn't just advance astronomy, it invented science as we know it. Their legacy isn't just in star charts or spheres, but in the fearless curiosity that still drives us to look up and ask, how does this work? Yet for all their brilliance, the Greeks knew their limits. Ptolemy himself wrote that his models were tools, not truths, a humility modern science often forgets. Their greatest lesson might be this: understanding the stars isn't about conquering the unknown, but learning to walk with it, one question at a time. The Chinese didn't just map the stars, they built a celestial empire in the sky. Imagine an astronomer in the Han Dynasty crouching over a lacquered wooden board, painting stars with a fine brush dipped in vermilion ink. Each dot wasn't merely a point of light, it was a bureaucrat in heaven's vast administration. The North Star, that was the purple forbidden enclosure, home of the celestial emperor. Surrounding constellations became his ministers, generals, and even prisons for disobedient spirits. This wasn't poetry, it was a meticulously organized bureaucracy mirrored in the heavens, where every star had rank and responsibility. Now consider the Dunhuang Star Atlas, discovered in a sealed cave library along the Silk Road. Dating to around 700 AD, this stunning scroll depicts over 1,300 stars across 28 lunar mansions, the ancient Chinese equivalent of zodiac sectors. But what's astonishing isn't just its age or detail, it's the precision. Stars are color-coded, white for the visible, black for those lost to twilight, and even red for ominous comets. Some constellations are drawn with dotted lines, others connected like celestial paperwork flowing between departments. This wasn't art for art's sake. It was a functional document used by court astronomers to predict everything from harvest cycles to rebellions. Chinese stargazing blended science with statecraft in ways that would baffle modern minds. When a guest star, what we now call a supernova, appeared in 1054 AD, imperial astronomers recorded its exact position near Taurus for months until it faded. Today, we recognize this as the Crab Nebula's violent birth, but to the Song dynasty court it was a cosmic memo, a sign requiring interpretation. Was it an omen for the emperor's health? A warning about border conflicts. Even comets had job titles: broom stars that swept away bad governance, or fuzzy stars signaling coming droughts. The tools they used reveal this dual purpose. The armillary sphere, perfected by Zhang Heng in the 2nd century, wasn't just for observation. Its rings mirrored the hierarchy of heaven, with the celestial equator as the emperor's path and planetary movements as ministerial reports. Star maps were often buried in tombs, not just as navigational aids for the afterlife, but as bureaucratic credentials, proof the deceased could navigate heaven's paperwork. What makes Chinese astronomy so fascinating is its sheer endurance. While Babylonian clay tablets crumbled and Greek texts were lost, China's imperial astronomers maintained continuous records for over 2,000 years. When Kepler studied supernova in the 17th century, he relied on their data. Modern astrophysicists still reference their comet sightings to track orbital changes. This longevity stems from a unique worldview. The cosmos wasn't separate from human affairs. A well-ordered sky meant a well-ordered empire, and vice versa. Yet beneath this rigid system lay breathtaking innovation. The same culture that saw stars as officials also invented the first celestial globe, pioneered eclipse prediction, and debated whether the moon's light was reflected sunlight centuries before the West. Their star maps weren't just mirrors of earthly power, they were bridges between the measurable and the mystical, where mathematics met meaning. In an age when we've reduced the night sky to coordinates and pixels, there's something profoundly human in remembering a time when stars weren't just objects, but characters in the greatest story ever told. Deep in the Australian outback, under a sky so vast it seems to swallow the earth whole, Aboriginal elders still point to a constellation most of us would miss, not a cluster of bright stars, but the dark spaces between them. This is the emu in the sky, its long neck stretching across the Milky Way, its body formed by the dust lanes that obscure starlight. To the Wardaman people, when the emu's posture shifted, its head dipping toward the horizon in April, it signaled the start of the egg-laying season. Time to gather emu eggs for food. By October, as the emu appeared to stand upright, the eggs had hatched and hunting season began. This wasn't just stargazing, it was a celestial calendar etched in negative space, a reminder that sometimes what's absent speaks louder than what's there. Meanwhile, in the frozen expanse of the Arctic, the Inuit navigated a world where landmarks vanished under snow and the sun disappeared for months, their lifeline. The North Star, or Nutuituk, the one that never moves, but their brilliance lay in reading the subtle cues around it. They noticed how sea ice reflected starlight differently than open water, how snowdrifts aligned with prevailing winds, and how the aurora's shimmer could reveal distant mountain ranges. Stars weren't just guides, they were part of a sensory symphony. A skilled navigator could feel the ice beneath their feet, listening for the creaks that signaled thin spots, while simultaneously tracking the stars above. This wasn't navigation as a separate skill. It was a way of being, woven into every aspect of survival. What tied these traditions together was their reliance on orality. The Aboriginal songlines, dreaming tracks that crisscross the continent, encoded navigation routes in melodies, with each verse marking a change in terrain or a sacred site. An elder singing the Star Ancestor cycle wasn't just telling a story. They were reciting a map, one that could guide a traveler hundreds of miles with pinpoint accuracy. Similarly, Inuit elders taught star lore through throat-singing duets, where rhythmic pulses mimicked the steady movement of constellations across the sky. These methods did more than preserve knowledge. They embedded it in culture, making it inseparable from language, art, and identity. Today, this wisdom hangs by a thread. With younger generations drawn to digital screens over night skies, elders whisper urgent pleas to document what remains. In Australia, projects like the Indigenous Astronomy revival train teenagers to read the emu signals, blending smartphone apps with ancient stories. In Nunavut, Inuit elders work with glaciologists, using traditional star-based ice predictions to track climate change. These collaborations reveal a startling truth. Indigenous star knowledge isn't a relic, it's a living science, offering solutions modern technology overlooks. Perhaps that's the real lesson of these star maps. They remind us that navigation was never just about reaching a destination. It was about understanding your place in a story written across the sky, a story of seasons, of ancestors, of the delicate balance between Earth and cosmos. When an Inuit hunter looks up at Nutuituk or a Wardaman elder traces the emu's shadow, they're not just finding their way, they're remembering how to belong to the world. To ancient sailors drifting on the open ocean, the Big Dipper wasn't just a celestial spoon, it was a lifeline. By tracing an imaginary line from the two stars at the end of its bowl, navigators could find Polaris, the North Star, a fixed point in the spinning sky that never wavered more than 1 degree from true north. This simple trick worked so reliably that Viking explorers used it across the North Atlantic, their longships cutting through fog and darkness with nothing but wooden sundials and this unshakable stellar anchor. But here's what's extraordinary. The same stars that guided Norse raiders also steered Chinese treasure fleets and Arab dhows, proving that the night sky was the first truly global GPS. Meanwhile, in the southern hemisphere, where Polaris disappears below the horizon, sailors relied on a different celestial signpost, the Southern Cross. These 4 bright stars, arranged like a kite, became the compass for Polynesian voyagers and Portuguese explorers alike. By extending the long axis of the cross 4.5 times downward, navigators could pinpoint the south celestial pole, an invisible anchor point crucial for plotting courses through uncharted waters. The brilliance of this system lay in its adaptability. When British astronomer James Cook mapped the Pacific in the 1700s, he used the same technique as the Maori navigators who'd crossed those seas centuries before, proving that stellar knowledge transcended language and culture. Yet constellations were never just practical tools. They were cultural mirrors reflecting the values and fears of the societies that named them. the Greeks saw Orion as a mighty hunter, forever pursuing the Pleiades across the sky. But to the Lakota people, those same stars formed the Hand constellation, its fingers pointing toward the spirit world. The Egyptians envisioned the Milky Way as the celestial Nile, while the Inca saw it as a cosmic river where llamas drank. These differences weren't arbitrary, they encoded entire worldviews. When the Babylonians divided the zodiac into 12 signs, they weren't just mapping stars, they were creating a divine bureaucracy where each constellation governed earthly affairs from harvests to royal births. What's often overlooked is how these star patterns shaped human exploration on land as well as sea. Desert caravans from Timbuktu to Samarkand used Scorpius to time their crossings, knowing its appearance signaled the end of deadly summer heat. The Dogon people of Mali aligned their villages with Sirius, the brightest star in the sky, which they believed held the secrets of creation. Even the layout of ancient cities often mirrored celestial patterns. The 3 pyramids of Giza aligning with Orion's belt, or Teotihuacan streets matching the Pleiades' rise. This shared celestial language reveals a profound truth. Before borders or written languages, humanity had a common vocabulary written in starlight. Whether carved into Babylonian clay or sung in Polynesian chants, these constellations were more than navigation aids. They were the original social network, connecting cultures across continents and centuries through a silent dialogue of light. And that's a legacy still written above us every night, waiting to be read by anyone who knows how to look up. The night sky didn't just guide explorers, it shaped the fate of empires. When Roman legions marched beyond the Alps, they didn't rely solely on roads or scouts. They carried portable sundials and star charts calibrated to specific latitudes. These weren't mere gadgets but instruments of conquest, ensuring armies could coordinate attacks across vast territories with eerie precision. Historical records reveal that Julius Caesar timed his invasion of Britain to coincide with the autumnal equinox, when predictable tides and lingering daylight gave his troops an edge. The stars for Rome were silent generals in their campaigns, dictating when to strike and when to hold back. Genghis Khan's Mongol hordes took celestial strategy even further. Their scouts, trained to navigate the featureless steppes by memorizing star patterns, could traverse hundreds of miles in darkness without torches, avoiding detection while encircling enemies. The Khan's famous postal system, the Yam, used star-aligned relay stations to deliver messages faster than any European courier, but their true brilliance lay in psychological warfare. By launching attacks during meteor showers or lunar eclipses, they convinced foes the heavens themselves favored the Mongols, turning celestial events into weapons of terror. At sea, the Vikings elevated star navigation to an art of war. Their longships often raided under cover of new moons when darkness hid their approach. Sagas recount how navigators used sunstones, possibly calcite crystals that polarized sunlight, to locate the sun even through dense cloud cover. This gave them a tactical advantage in the North Atlantic's foggy waters, where other fleets drifted blindly. The infamous raid on Lindisfarne in 793, historians now suspect it was timed to the summer solstice, when extended twilight allowed the Norse to strike and retreat under optimal conditions. Even the pyramids of Giza, often studied for their spiritual alignments, may have served military purposes. The air shafts in the Great Pyramid don't just point to Orion's belt. They align with stars that mark the Nile's annual flooding. Control this celestial calendar, and you controlled Egypt's agricultural cycle, the lifeline of any army. Later pharaohs like Ramses Roman II used similar astronomy to coordinate battles, ensuring their chariots charged under constellations associated with their patron gods. What united these strategies was a ruthless pragmatism. The stars weren't just mystical symbols, they were leverage. When Alexander the Great besieged Tyre in 332 BCE, his engineers waited for Sirius to rise, signaling the seasonal winds that would carry their siege towers across the water. When Polynesian warriors launched inter island raids, they timed voyages to the zenith stars of their targets, ensuring surprise arrivals. Even the Napoleonic Wars saw officers using lunar distance calculations to synchronize troop movements across continents. This dark legacy reminds us that humanity's relationship with the heavens was never purely noble. The same stars that guided explorers to new horizons also steered armies toward conquest, their cold light illuminating both discovery and destruction. Yet in that duality lies a profound truth. Knowledge of the cosmos has always been power, and power, as the ancients knew, is rarely wielded gently. The magnetic compass didn't just change navigation, it rewired humanity's relationship with the sky. When Chinese inventors first suspended a lodestone on silk threads around 200 BCE, they unlocked a revolution. Suddenly, sailors could find north even when clouds obscured the stars, turning what was once an art form into something anyone could replicate with a floating needle. By the time Portuguese explorers like Vasco da Gama rounded the Cape of Good Hope in the late 15th century, celestial navigation had become a secondary skill. The stars were no longer the primary guide, just a reference point to double-check the compass's reliability. Yet the real death knell for star-based navigation came with the chronometer in the 1700s. John Harrison's H4, a pocket-sized clock that could keep accurate time at sea, solved the longitude problem that had stumped astronomers for centuries. Now, a sailor could compare local noon, determined by the sun's highest point, with the time back at their home port, calculating their position with unprecedented precision. The night sky, once an essential map, became more like a decorative backdrop, consulted only when technology failed. Even so, celestial navigation clung to life in unexpected ways. During World War II, bomber crews flying over featureless oceans still learned to shoot star sightings with sextants, a skill that saved lives when radio silence was crucial. The Apollo astronauts, despite relying on cutting-edge computers, trained in star recognition as a fail-safe. Neil Armstrong famously realigned the lunar module's guidance system using a sextant and the Earth's terminator line. Today, the U.S. Navy and Merchant Marine academies still teach celestial navigation, not out of nostalgia, but because solar flares or cyber attacks could knock out GPS satellites in an instant. What's fascinating isn't just the persistence of these skills, but the cultural shift they represent. Ancient Polynesians didn't just know the stars, they felt them, their bodies attuned to subtle shifts in swells and breezes that modern instruments can't replicate. Compare that to a contemporary cargo ship captain, who might spend an entire crossing staring at digital displays rather than the horizon. The cost of convenience is a kind of sensory atrophy, where we no longer trust our own observations. Yet the stars haven't entirely surrendered their role. Amateur astronomers and wilderness survivalists keep the old techniques alive, proving that this knowledge isn't obsolete, just dormant. In remote parts of Alaska, Inuit elders teach children to navigate by the moon's reflection on ice, a skill that saved lives when GPS devices freeze. The irony is palpable. As our technology grows more fragile, vulnerable to battery failures, hacking, or orbital debris, the sky remains the one system that can't be hacked or unplugged. This duality defines our modern relationship with celestial navigation. We've traded intimacy for efficiency, depth for speed, but somewhere between the glow of a smartphone map and the ancient practice of tracing Orion's belt, there's a middle ground, a recognition that the stars aren't just a relic, but a resilient language waiting to be spoken again when the screens go dark. In a quiet lab at the University of Hawaii, a team of historians huddles around a 3D projection of the night sky, but not as it appears today. With a few keystrokes, they wind back the clock 2,000 years, watching constellations shift to match the exact positions Polynesian navigators would have seen from their canoes. This isn't just digital stargazing, it's detective work. By combining satellite data with oral histories, they've reconstructed forgotten star paths, proving that chants passed down for generations contain precise celestial coordinates. One chant, previously dismissed as myth, led researchers to a specific cluster of stars near the horizon, a navigation marker for voyages between Tahiti and the Marquesas. The ancients weren't just telling stories, they were encoding survival manuals in song. Meanwhile, halfway across the world, archaeologists armed with laser scanners are uncovering another layer of the puzzle. At Chichen Itza, LiDAR technology revealed hidden alignments in the Mayan pyramids, their staircases designed to frame Venus at its brightest, while shadow patterns during equinoxes transform the steps into a slithering serpent of light. These aren't mere coincidences. When researchers input the same astronomical data into software used by modern architects, they found the margin of error was less than half a degree. The Maya didn't just build temples, they engineered celestial calendars in stone. The revival of Polynesian wayfinding aboard the Hokulea has become the ultimate test of these rediscovered techniques. On its maiden voyage in 1976, the crew relied solely on traditional methods: no compass, no charts. When they reached Tahiti after 34 days at sea, landing within miles of their target, it wasn't just a triumph of seamanship. It was validation that knowledge preserved in chants and stick charts could outperform satellite navigation under the right conditions. Today, the Hokulea continues to train new navigators, blending millennia-old star knowledge with modern safety protocols, proving that ancient wisdom doesn't have to compete with technology, it can complement it. Archaeoastronomers are now applying these lessons to solve historical mysteries. In Egypt, researchers used software to simulate the night sky during the construction of the Great Pyramid. They discovered that its air shafts align not just with Orion's belt, but with specific stars that marked the Nile's flood season, a celestial alarm clock for agriculture. Similarly, analysis of England's Stonehenge revealed that its station stones form a perfect rectangle aligned to lunar standstills, events that occur only every 18.6 years. These finds suggest that ancient astronomers didn't just observe the sky, they predicted its cycles with mathematical precision. What's emerging from this research is a radical reassessment of premodern science. The Dogon people of Mali, long ridiculed for claiming their ancestors knew about Sirius's invisible companion star, were recently vindicated when telescopes confirmed Sirius B's existence, a star impossible to see without advanced optics. How they knew remains debated, but their oral traditions describe its elliptical orbit with eerie accuracy. Likewise, Inuit elders' descriptions of star trails on sea ice now help climatologists track Arctic melt patterns, their celestial terminology providing clues about historical weather shifts. This isn't romanticizing the past, it's recognizing that ancient stargazers achieved feats we're only now beginning to measure, and that their techniques might still hold answers. When NASA engineers study Inca Quipu knots for data storage ideas, or when sailors relearn Polynesian wave reading to reduce reliance on fragile electronics, they're acknowledging a profound truth: sometimes the oldest solutions are the most resilient. The stars that guided humanity for millennia haven't changed. Perhaps it's our way of seeing them that needs renewal. Consider the precision required to align the Great Pyramid's corridors with Orion's belt to within a fraction of a degree. Without telescopes or satellites, the ancient Egyptians achieved this by turning patience into a science. generations of priests meticulously recorded star positions on temple walls, noting subtle shifts over decades. They didn't just watch the sky, they became living calendars, their observations fine-tuned by rituals timed to celestial events. When the pyramid's builders laid its foundation, they didn't guess where north was. They used the circumpolar stars, which never set, as a fixed reference. By tracking the simultaneous transit of two stars, Mizar and Kochab, across a plumb line, they could pinpoint true north with an error margin smaller than modern compasses. This wasn't luck, it was the cumulative work of lifetimes, a kind of slow science we've all but forgotten. Stonehenge reveals another layer of this precision. The heel stone, positioned outside the main circle, catches the first light of the summer solstice sunrise, casting a beam that pierces the heart of the monument. But recent laser scans show the entire site is riddled with smaller alignments, lintels marking lunar standstills, posts aligned to midwinter sunsets. Archaeoastronomers discovered that the Aubrey holes, a ring of pits once dismissed as ceremonial, actually functioned as a predictive calendar. By moving markers between these pits every year, Bronze Age observers could track the 18.6-year lunar cycle, anticipating eclipses with startling accuracy. The stones weren't just a temple, they were a celestial computer, its code written in shadow and light. What's often overlooked is the role of repetition in ancient astronomy. The Babylonians didn't just record Venus's movements, they compared observations spanning centuries, spotting patterns like the 8-year cycle where Venus returns to the same point in the sky. Their clay tablets contain lists of eclipses stretching back 600 years, so precise modern astronomers use them to study changes in Earth's rotation. This long-game approach transformed random events into predictable rhythms. When a Greek named Meton proposed the 19-year lunar cycle in 432 BCE, he was likely building on Mesopotamian records older than his civilization. The real breakthrough, though, came from tools we'd consider rudimentary. Take the Merkit, an Egyptian device made of a palm rib and a weighted string. Used as a simple sighting tool, it could measure star angles with surprising accuracy. Or the Polynesian Cape Hu Wetu, a hand-spread method where each finger width represented about 2 degrees, a technique still taught in Pacific navigation schools today. These weren't crude substitutes for technology, they were elegantly adapted to human perception, leveraging our innate ability to detect patterns. This precision shatters the myth that ancient science was steeped in superstition. When the Maya calculated Venus's synodic period, the time it takes to return to the same position, as 584 days, they were off by just 2 hours. Their Dresden Codex contains tables predicting planetary movements centuries into the future, with corrections for leap days. Similarly, Chinese records of Halley's Comet appearances, stretching back to 240 BCE, match modern orbital calculations. These weren't lucky guesses, they were the result of rigorous, iterative observation, a testament to what the human mind can achieve when it truly commits to watching the sky. Perhaps the most humbling lesson lies in how they compensated for limitations. Without telescopes, ancient astronomers developed workarounds that border on genius. The Greeks, for instance, used the moon as a mirror, measuring the angle between it and the sun during a half-moon phase to calculate celestial distances. Aboriginal Australians observed how starlight twinkled differently when reflected off distant waterholes, creating a natural interferometer to gauge atmospheric conditions. These methods reveal a truth modern science sometimes forgets. Innovation isn't just about better tools, it's about better seeing. Nowhere is this clearer than in the survival of these techniques against all odds. When Polynesian navigation was nearly erased by colonization, elders in Micronesia preserved it through etak, a star compass system memorized through chants. Today, it's taught alongside GPS in maritime academies, not as a relic but as a viable backup when satellites fail. The stars these ancients followed haven't changed. Only our willingness to look up has. The Greek myth of Orion the hunter paints a vivid picture: a giant striding across the sky, his belt of 3 bright stars unmistakable even to modern eyes. But hidden within this tale of Artemis and Scorpius might be something unexpected, a record of actual celestial events. Every year around late October, Earth passes through debris left by Halley's Comet, creating the Orionid meteor shower. To ancient observers, these streaks of light might have seemed like arrows from Orion's quiver, or perhaps the sparks of his divine battles. The timing aligns eerily with harvest festivals dedicated to the constellation, suggesting the myth wasn't just entertainment, it was a way to mark an annual astronomical phenomenon. Now consider the Dogon people of Mali, whose oral traditions describe Sirius B, the invisible companion star to Sirius A, centuries before telescopes confirmed its existence. Their legends speak of a tiny, dense star made of a metal heavier than iron, orbiting Sirius every 50 years, a startlingly accurate description of what astronomers later classified as a white dwarf. Skeptics argue this knowledge could have come from contact with modern astronomers, but Dogon elders insist these stories predate European contact by generations. Whether through ancestral observation or some lost method of stargazing, their lore captures a cosmic truth science took millennia to verify. What's fascinating is how these myths functioned as early scientific models. The Babylonian epic of Marduk slaying Tiamat, a chaos dragon, might symbolize Jupiter's retrograde motion, a planet appearing to battle the fixed stars as Earth overtakes it in orbit. Similarly, the Maori story of Ranginui, the Sky Father, being forcibly separated from Papatuanuku, the Earth Mother, mirrors the scientific concept of cosmic differentiation, the separation of celestial bodies from a primordial mass. These weren't just poetic metaphors, they were frameworks for understanding forces too complex to explain otherwise. Even seemingly whimsical star lore often held practical lessons. The Inuit tale of Sedna, the sea goddess whose fingers became seals and whales when she clung to her father's kayak, correlates with the Pleiades cluster's appearance heralding the spring hunting season. The aboriginal emu in the sky not only marked egg-laying cycles but also served as a territorial map, with different groups recognizing variations in the dark nebulous shape that corresponded to local landscapes. These stories did more than explain the cosmos, they encoded survival strategies, turning the night sky into a classroom where every generation learned from the last. The line between myth and reality blurs further when we examine how these narratives were preserved. The Norse used skaldic poetry with its intricate rhyme schemes to memorize star paths, a mnemonic device ensuring navigational knowledge survived even in illiterate societies. Maya astronomers depicted Venus not just as a god but as a war augury, their codices detailing its cycles with mathematical precision beneath the veneer of mythology. This duality reveals a profound truth. Ancient cultures didn't separate science from storytelling. They wrapped one in the other, creating vessels sturdy enough to carry truth across centuries. Perhaps that's the real genius of these star myths. They weren't just attempts to explain the cosmos. They were tools for transmitting complex knowledge in an age before textbooks or databases. When a Greek child heard of Orion's demise, they weren't just learning a moral lesson, they were absorbing celestial mechanics. When a Dogon elder spoke of Sirius's heavy star, they were preserving astrophysics in oral form. The night sky was humanity's first library, and its myths were the books written in light, bound by time, and waiting for those who knew how to read between the stars. Long before the tick of mechanical clocks or the glow of digital displays, humanity kept time by the silent dance of stars across the night sky. The Egyptians didn't just gaze at the heavens, they sliced the darkness into 12 precise hours, each marked by the rise of specific constellations they called decans. Picture a priest in Thebes standing atop a temple at dusk, watching as Sirius first pierced the twilight. That moment didn't just signal the annual Nile flood, it reset Egypt's celestial clock, dividing the night into segments as reliable as any modern timepiece. But here's what's astonishing. Their system accounted for the shifting night lengths across seasons. Summer hours stretched longer than winter ones, a fluid concept of time that modern, rigid timekeeping forgot. Meanwhile, halfway across the world, Maya astronomers were conducting their own celestial chronometry with breathtaking precision. Their Dresden Codex contains Venus tables so accurate they could predict the planet's appearances 500 years into the future. Why such obsession with Venus? Because it cycles 260 days as the morning star, another 50 disappearing, then 260 as the evening star became the heartbeat of Maya civilization. Wars were timed to its movements, with rulers launching campaigns only when Venus rose as the morning star, believing its light granted divine favor. Even their infamous calendar, often misunderstood as predicting apocalypses, was really a layered masterpiece combining a 260-day sacred cycle with a 365-day solar year, synchronized every 52 years to prevent seasonal drift. This wasn't just timekeeping, it was cosmic engineering. The Chinese took it further, turning astronomy into statecraft. Imperial observatories like the one in Beijing didn't just track stars, they enforced a calendar so authoritative that altering it without permission was treason. When Jesuit missionaries brought European astronomy to China in the 17th century, they were shocked to find the locals already correcting for precession, a wobble in Earth's axis that shifts star positions over centuries. The Chinese had documented this drift since the Han Dynasty by comparing ancient records, a feat akin to detecting a minute change in a clock's ticking over 2,000 years. What tied these systems together was their inseparability from daily life. In Babylon, the appearance of the Pleiades at dawn meant the barley harvest began. For the ancestral pueblones of Choco Canyon, petroglyphs aligned so that dagger-shaped sunlight would strike spiral carvings only during solstices, signaling when to store food or begin migrations. Even Stonehenge's heel stone, framing the summer solstice sunrise, likely served as a deadline for tribal gatherings, an ancient save-the-date written in sunlight. This celestial timekeeping reveals a profound truth about our ancestors. They didn't just measure time, they conversed with it. Where we see numbers on a clock, they saw stories. The death and rebirth of sun gods at winter solstice, the marriage of moon and star during eclipses. Their clocks weren't devices but drummers, performed nightly across the stage of the sky. And perhaps that's what we've lost in our atomic precise era, not accuracy, but the artistry of time itself. The flames that consumed the Library of Alexandria didn't just burn papyrus, they erased entire constellations of human understanding. Among its lost treasures were star catalogues from Babylon, celestial maps from Greece, and treatises by scholars like Aristarchus, who proposed a heliocentric solar system 2,000 years before Copernicus. One account mentions a revolving mechanical sphere that displayed planetary motions, an ancient planetarium lost to history, but Alexandria wasn't alone. In China, Emperor Qin Shi Huang ordered the burning of astronomical texts in 212 BCE to consolidate power, wiping out centuries of celestial records. The Maya codices that survived Spanish bonfires are mere fragments, their bark paper pages preserving only glimpses of a sophisticated system that tracked Venus with near-modern precision. What's often overlooked is how these losses ripple through time. When Islamic scholars translated Greek texts in the Middle Ages, they worked from copies of copies, each generation adding errors like a celestial game of telephone. Ptolemy's star coordinates, already slightly off due to precession, became further distorted in translation. A 10th century Arabic manuscript might list a star's position based on a 6th century Byzantine copy of a 3rd century Roman edition of a 1st century Greek original. Small wonder medieval European maps placed stars in the wrong hemispheres, yet even these flawed copies became priceless when the originals vanished, proving that imperfect preservation beats perfect oblivion. Indigenous knowledge faced a different kind of erosion. When British colonists banned celestial navigation practices in the Pacific, they didn't just outlaw tools, they severed a living chain of oral transmission. Polynesian star chants, memorized over decades of apprenticeship, faded as elders died without successors. In Australia, Aboriginal songlines where constellations mapped sacred routes across the land were dismissed as primitive myths. Only recently have researchers realized these songs encoded precise navigational data, like the Ngarrindjeri people's use of the Southern Cross to time egg collection from tidal flats. The suppression wasn't just cultural violence, it was the silencing of entire scientific traditions, but resilience flickers in unexpected places. A 13th century monk in Iceland, unaware of its significance, copied a star list from a water-damaged Greek manuscript onto the back of a sheepskin prayer book, preserving coordinates that later helped astronomers reconstruct precession rates. A single Mayan codex, the Dresden, survived Europe's book burnings by sheer chance, its Venus tables proving the sophistication of Mesoamerican astronomy. Even colonial records sometimes inadvertently preserved what they sought to erase. Spanish missionaries in the Andes documented Inca sky observations while trying to replace them with European astrology, leaving clues for modern scholars to reconstruct indigenous knowledge. The most poignant survivals live in everyday objects, a Cherokee basket weaving pattern that mirrors the Pleiades arrangement, a Norse sundial found in Greenland, its notches adjusted for latitude by Viking navigators. The alignment of Hawaiian Heiau temples to the rising of Macaulay Pleiades for Makahiki season. These aren't just artifacts, they're dormant star maps waiting to be read. What's at stake isn't just historical curiosity. When the last Polynesian PWO navigator Maupiailug shared his knowledge with outsiders in the 1970s, he didn't just pass on star paths, he reignited a technology that doesn't rely on satellites or batteries. Similarly, Dogon Elder's star lore, once mocked, now intrigues astrophysicists studying Sirius B. These fragments remind us that ancient astronomy wasn't a primitive prelude to modern science. It was a parallel path with its own breakthroughs and blind spots, some of which might still hold untapped insights. The real tragedy isn't how much we've lost, but how much we assume was never there to begin with. Every time a researcher deciphers star symbols on a Babylonian tablet or matches an oral tradition to an astronomical event, we recover not just facts but ways of seeing. The night sky these ancients mapped is the same one above us tonight. Their lost libraries whisper that the stars remember what we've forgotten. When Homer described Odysseus clinging to his raft in the wine-dark sea, gazing at the Pleiades and Boötes as they, late in the season, set, he wasn't just painting a poetic image, he was documenting a real survival technique. The Odyssey, composed nearly 3,000 years ago, reads like a masterclass in celestial navigation. Calypso directs Odysseus to keep the Great Bear constellation on his left as he sails east, an instruction that would have helped any ancient mariner maintain course. But here's what's extraordinary. Homer's star references align with archaeological evidence. Mycenaean frescoes depict similar constellations, suggesting these celestial markers were common knowledge long before they were immortalized in verse. The poem isn't just literature, it's a coded survival manual wrapped in epic storytelling. Centuries later, Dante's Divine Comedy took celestial navigation to metaphysical heights. In Paradiso, the poet ascends through celestial spheres like a sailor climbing latitudes, each heaven corresponding to a planet's influence. When Beatrice explains how the fixed stars imprint virtues on souls, she's echoing actual medieval navigation techniques, where sailors believed stars imbued winds and tides with specific qualities. Dante's cosmic journey mirrors the portolan charts of his era, where compass roses and room lines connected earthly travel to divine order. The night sky wasn't just a map for Dante, it was a ladder between the human and the holy. Shakespeare's plays reveal how deeply star lore permeated everyday life. In Julius Caesar, Cassius boasts, "The fault, dear Brutus, is not in our stars," a line that only lands if audiences understood astrology as a legitimate science. The Tempest's Prospero, exiled on an island, likely used Ursa Major to track time, just as real castaways did. Even Sonnet 14 claims, "Not from the stars do I my judgment pluck," playing on the era's debate over celestial influence. These weren't just pretty metaphors, they were proof that celestial navigation had jumped from practical skill to cultural shorthand, a language every theatergoer understood. Fast forward to modern sci-fi, and the stars still guide us, just through warp drives instead of wooden ships. In Frank Herbert's Dune, the Fremen navigate the desert by memorizing stars as meticulously as Polynesian wayfinders. The Expanse series revives celestial mechanics with brutal realism, where miscalculating a slingshot orbit around Jupiter can strand ships in the void. Even Interstellar's Tesseract scene, where Cooper manipulates time through gravitational anomalies, echoes ancient beliefs about stars bending fate. Science fiction didn't abandon celestial navigation, it reinvented it for the age of quantum physics. What binds these stories across millennia isn't just shared imagery, it's a shared recognition that stars are more than tools. They're mirrors. Homer saw guidance in Orion's belt, Dante saw divinity in the primum mobile, Shakespeare saw human folly reflected in wandering planets. When a 21st century astronaut in a novel gazes at Earth from Mars, tracing the same constellations their ancestors used, they're participating in the oldest dialogue humanity knows. Literature didn't just preserve navigation techniques, it preserved our timeless conversation with the night itself, a conversation where every generation adds new verses, but the stars keep singing the same chorus. The vast trade networks that stitched the ancient world together all shared one invisible guide: the stars. Picture a caravan of camels moving silently across the Silk Road's dunes, their path illuminated not by street lamps but by the steady glow of Polaris. Arab merchants timed their desert crossings to coincide with the autumn rise of Fomalhaut, a star whose appearance signaled the end of deadly summer heat. Meanwhile, in the Indian Ocean, traders from Gujarat to Guangzhou waited for the winter appearance of Canopus, its brilliant light guiding house laden with pepper and porcelain through monsoon winds. These weren't just journeys, they were celestial ballets choreographed by constellations that dictated when to sail, when to rest, and when to strike deals. What's often overlooked is the precision behind this stellar commerce. Phoenician ships navigating to Cornwall for tin didn't just follow the North Star, they tracked its altitude with their hands, stretching fingers against the horizon to estimate latitude. Each finger's width represented roughly 2 degrees, allowing them to judge when they'd reached Britain's southern coasts. Similarly, the Swahili traders of East Africa timed their voyages to the seasonal shift of the Southern Cross, knowing its tilt in April meant favorable winds for reaching India. The stars didn't just point the way, they whispered when to go. The Polynesians took it further, turning the Pacific into a highway of star paths. Their legendary Kavenga routes connected Tahiti to Hawaii, New Zealand to Easter Island, with precision that still baffles modern sailors. A master navigator knew that when the Pleiades dipped toward the horizon at dusk, it was time to tack north toward the Marquesas. They even read ocean swells like celestial road signs. The way waves refracting around an island created patterns recognizable even in darkness. This wasn't just navigation, it was a dialogue with the cosmos where every ripple and star spoke volumes. But the real magic lay in how these routes became conduits for more than goods. Along the Silk Road, Persian astronomers shared star charts with Chinese scholars, leading to hybrid constellations that blended myths across continents. In Calicut, Arab and Hindu navigators compared lunar eclipse predictions, merging Babylonian math with Vedic cosmology. Even the humble compass perfected by Chinese merchants reached Europe thanks to celestial traders who'd mapped its variations across latitudes. The stars didn't just guide commerce, they catalyzed the first global exchange of ideas. This interstellar economy had its risks. A misread star could strand a spice ship on Madagascar's reefs or bury a caravan in the Taklamakan sands. That's why celestial knowledge was so fiercely guarded. Venetian glassmakers secreted away star charts in blown glass spheres, while Ottoman captains kept logs encrypted with Quranic verse. The famous portolan maps of the Mediterranean, with their room lines radiating from compass roses, were state secrets worth more than their weight in saffron. Yet for all their secrecy, these traders left clues in plain sight. The alignment of medieval bazaars in Samarkand and Aleppo often mirrored celestial patterns, with gates facing sunrise on solstices. The layout of Angkor Wat's temples corresponds to the Draco constellation's shape, a celestial blueprint for earthly power. Even today, the names of goods betray their stellar heritage. Zenith comes from Arabic samt, meaning path, while monsoon derives from Mosim, the season when certain stars rose. The legacy of these star-guided merchants endures in unexpected ways. Modern shipping lanes still trace ancient routes first plotted by starlight. The phrase, steering by the stars, survives in boardrooms as a metaphor for strategy. And when astronomers today search for exoplanets, they use transit methods tracking starlight dips that echo how Polynesians detected distant islands by star distortions. The stars that once guided cloves and silk now guide satellites and probes, proving that humanity's oldest maps still chart the way forward. When we picture ancient astronomers, the image that often comes to mind is a bearded sage hunched over clay tablets, but history's celestial archives tell a different story. Hypatia of Alexandria wasn't just a philosopher. She was a master astronomer who designed astrolabes and mapped planetary motions with such precision that her murder in 415 CE sent shockwaves through the ancient world. Her lectures drew crowds from across the Mediterranean, proving women could dominate what we assume was a male intellectual space. Yet Hypatia was far from alone. In China, Empress Wu Zetian of the Tang dynasty didn't just support astronomy, she revolutionized it, commissioning star maps so detailed they included atmospheric refraction corrections centuries before Europe acknowledged the phenomenon. Her court astronomer, a woman named Wang Zhenyi, would later calculate lunar eclipses with nothing but a lamp, a mirror, and sheer genius, writing treatises that blended poetry and orbital mechanics. The real surprise lies beyond these famous names, in the quiet transmission of knowledge that kept civilizations aligned with the heavens. Polynesian grandmothers taught granddaughters to read the star compass, their chance-preserving navigation routes across thousands of ocean miles. In the Andes, Quechua women still weave textiles with constellation patterns that mirror Inca quipu records, each knot and color encoding solstice events. The Navajo honored women as star walkers, specialists who used the Pleiades' position to time corn plantings, a role so vital that disrupting their observations could mean famine. These weren't passive inheritors of knowledge, they were active scientists adjusting star law to climatic shifts, their observations fine-tuned across generations. What's revolutionary is how these women worked within, and sometimes around their society's constraints. The Greek astronomer Aglaonike, dismissed as a witch for predicting eclipses, likely used Babylonian records smuggled into women's quarters. Medieval nun Hildegard of Bingen disguised her celestial theories as religious visions, embedding orbital diagrams in illuminated manuscripts. Even the few surviving Babylonian tablets bearing women's names, like the priestess Enheduanna's lunar records, hint at networks of temple astronomers whose contributions were systematically erased. The proof emerges in unexpected places. A recently decoded Egyptian star chart from 1200 BCE contains marginal notes in a woman's handwriting, correcting a scribe's planetary calculations. In Japan, court ladies of the Heian period kept precise diaries tracking Jupiter's loops, their data later used to validate modern astronomical models. The most poignant evidence might be the anonymous fingerprints pressed into Mayan codices. Analysis shows many belonged to women, their hands smoothing bark paper pages filled with Venus tables. This hidden history changes how we view ancient science. When Polynesian double-hulled canoes reached New Zealand or Babylonian priests predicted eclipses, women's minds and hands helped steer those achievements. The night sky wasn't charted by lone geniuses but by collective wisdom, mothers teaching star rhymes, queens funding observatories, priestesses tracking celestial cycles. Recognizing their roles does more than correct the record. It reveals astronomy's true nature as a human endeavor, boundless as the cosmos they studied. Imagine a spacecraft hurtling toward Mars, its computers suddenly silent after a solar flare wipes out all electronics. In that moment of darkness, the crew's survival might hinge on a tool older than written language, a star chart. NASA Advanced Exploration Systems Division has been quietly studying Polynesian wayfinding and Babylonian star logs, not as historical curiosities, but as potential lifelines for interstellar travel. Their reasoning is stark. In the void between planets where GPS signals can't reach and radio delays make real-time guidance impossible, the stars remain the only constant. Engineers are now testing sextants aboard the International Space Station, proving that these ancient instruments can determine a spacecraft's position within 3 miles, even in orbit. Meanwhile, back on Earth, light pollution has erased the Milky Way from 1/3 of humanity's view, but an unexpected counter-movement is brewing. Amateur astronomy clubs from Tokyo to Tucson are hosting naked eye navigation workshops, teaching urbanites to recognize key constellations without apps or telescopes. In Norway, where GPS jamming by military exercises has stranded hikers, outdoor schools have revived Viking star techniques using nothing but fists held at arm's length to measure angles. The irony is palpable. As our digital maps grow more precise, their fragility is driving us back to the original infallible system, the sky itself. The real revolution, though, may be happening in Silicon Valley. Startups are developing augmented reality visors that overlay ancient star paths onto modern cityscapes, allowing users to see through light pollution to the constellations beneath. One prototype uses AI to translate Babylonian clay tablet data into real-time star positions, effectively resurrecting 4,000-year-old knowledge as a functional tool. Even astronauts are joining the revival. ESA's latest training includes sessions with Hawaiian navigators, blending laser-ranging tech with traditional wave-reading skills to prepare for lunar landings where satellite coverage is patchy. This isn't nostalgia, it's adaptation. When the Mars Perseverance rover's autonomous navigation failed during a dust storm, engineers manually plotted its course using the sun's position, a technique straight from 18th century naval manuals. Private space stations like those planned by Axiom intend to install transparent observation domes not just for morale, but as emergency navigation aids. The lesson is clear. In environments where failure isn't an option, redundancy isn't just about backup circuits, it's about preserving ways of thinking that have kept humans oriented for millennia. Perhaps the most poetic twist is how space colonization could complete the circle. Future settlers on Proxima Centauri b won't just gaze at unfamiliar constellations, they'll decode them, just as their ancestors did, turning patterns into pathways. Already, astrophysicists are drafting interstellar roadmaps using pulsars as cosmic lighthouses, their steady flashes serving as the new Polaris. The stars that once guided us across oceans may soon guide us between solar systems, proving that some tools aren't outdated, they're just waiting for their next voyage. What ancient navigators understood and were rediscovering is that technology isn't about replacing nature's wisdom, but amplifying it. The night sky isn't a relic, it's a living library, its pages written in starlight, waiting for readers bold enough to look up and remember. The idea that ancient star maps must be the work of extraterrestrials says more about our own skepticism than it does about history's greatest astronomers. Take the Dogon people of Mali, whose detailed knowledge of Sirius B, a star invisible to the naked eye, has fueled speculation for decades. But here's what often gets overlooked. French anthropologists visited the Dogon in the 1930s, right around the time European telescopes had confirmed Sirius B's existence. It's far more plausible that this cultural exchange, not alien visitation, explains their celestial insights. The real marvel isn't whether beings from another world shared secrets, it's how human curiosity and collaboration bridged gaps in understanding long before modern science filled them. Consider the precision of Babylonian eclipse records. Some theorists argue their predictions were too accurate to be human-made, ignoring the fact that these astronomers had centuries of meticulously preserved data at their fingertips. Their clay tablets reveal something extraordinary, generations of scholars building on each other's work, spotting patterns in the chaos, turning celestial events from terrifying omens into predictable phenomena. When they noted that lunar eclipses recurred every 18 years in the Saros cycle, it wasn't because aliens whispered the secret, it was because they had the patience to watch, record, and connect the dots over lifetimes. Then there's the Antikythera mechanism, a 2,000-year-old Greek device often hailed as too advanced for its time. This intricate bronze gear system predicted planetary positions and eclipses with startling accuracy. But calling it alien technology dismisses the brilliant minds who crafted it. Recent scans show its design aligns perfectly with Babylonian math and Greek engineering, a proof of how knowledge traveled along trade routes, not from other planets. The device wasn't a fluke. It was the product of a Mediterranean world where ideas flowed as freely as olive oil and spices. What these theories underestimate is the sheer tenacity of ancient scientists. Polynesian navigators didn't need star charts handed to them by visitors from space. They spent years memorizing the night sky's subtle shifts, testing their knowledge on perilous open ocean voyages. The Maya didn't require extraterrestrial help to track Venus. They simply had scribes who recorded its movements across generations, spotting cycles we now confirm with supercomputers. To attribute their achievements to aliens isn't just inaccurate, it's a disservice to the human intellect's capacity for observation, innovation, and relentless problem-solving. The most compelling evidence against these myths lies in the mistakes. Ancient astronomers weren't infallible. Ptolemy's geocentric model, though mathematically elegant, was dead wrong. Chinese records sometimes misidentified comets as celestial omens. These errors aren't proof of human limitation, they're proof of human learning. Every miscalculation, every corrected assumption, shows cultures refining their understanding through trial and error, not passively receiving wisdom from the stars. So why does the alien narrative persist? Perhaps because it's easier to imagine cosmic intervention than to accept how much knowledge has been lost to time, war, and disaster. The Library of Alexandria's burning didn't just destroy books, it erased entire lineages of thought. The colonial suppression of indigenous star lore severed living chains of wisdom. What survives is often fragmentary, making ancient achievements seem inexplicable when they're really just incomplete. The truth is far more inspiring. From Aboriginal songlines that encode stellar paths in melody to Inca quippers that knotted celestial data into chords, humanity's star maps were born of persistence, not providence. They remind us that the night sky isn't a mystery to be solved by outside forces. It's a conversation we've been having with the universe for millennia, one patient observation at a time. And that conversation continues every time we look up and wonder. There's a quiet irony in how ancient navigators crossed oceans with nothing but the stars, while today we panic when our phone batteries dip below 20%. The Polynesians didn't just glance at the sky, they spent years memorizing the subtle dance of constellations, learning to read the ocean's swells like lines in a book. Their greatest tool wasn't a compass or a chart, it was patience. In a world where we expect answers at the tap of a screen, their legacy whispers a radical idea: some knowledge can't be rushed. It's a lesson modern science ironically confirms. Studies show that students who learn celestial navigation develop sharper observational skills and spatial awareness than those relying solely on GPS. The stars, it seems, still teach us how to see. Then there's the art of observation, ancient astronomy's cornerstone. Babylonian priests didn't just record Venus's movements, they noticed patterns invisible to the casual viewer, like its 8-year cycle of reappearances. This habit of deep attention mirrors modern mindfulness practices. When a Navajo star walker tracks the Pleiades' position to time corn planting, or an Inuit hunter reads the night sky to predict sea ice, they're exercising a form of focus that screens constantly erode. Psychologists call this environmental attunement, the ability to read subtle natural cues. It's a skill that reduces stress and heightens awareness, one we've traded for push notifications. But perhaps the most profound lesson is respect for nature's rhythms. The Maya didn't just track Venus for war, they synchronized their entire agricultural calendar to its cycles. When the star appeared as the morning herald, they planted. When it vanished, they prepared for drought. This wasn't superstition, it was sustainability. Contrast that with modern farming, where artificial lights and climate-controlled greenhouses divorce crops from seasons, often at ecological cost. Indigenous star knowledge reminds us that efficiency shouldn't mean disconnection. Rediscovering these practices doesn't require abandoning technology. It's about balance. Norwegian hikers now blend GPS with Viking star techniques when traversing glaciers. Marine biologists study Polynesian wave reading to track ocean currents without disturbing marine life. Even urban stargazers use apps to identify constellations, then shut off their phones to simply watch the sky. The goal isn't to reject progress, but to reclaim something older, an intimacy with the cosmos that fuels both wonder and wisdom. In the end, ancient star maps offer more than navigation. They're mirrors reflecting how we've changed. When we slow down to trace Orion's belt or wait for Sirius to rise, we're not just stargazing. We're retraining minds numbed by speed, relearning the lost art of paying attention, not just to the heavens, but to the world around us. And that's a voyage no app can shortcut. Standing under a clear night sky today, the same stars that guided ancient explorers still shine unchanged, unwavering, and utterly accessible to anyone willing to learn their language. You don't need a Babylonian clay tablet or a Polynesian stick chart to start. All it takes is knowing a single anchor point, Polaris, the North Star. Found at the end of the Little Dipper's handle, this steadfast beacon sits almost directly above Earth's northern axis, making it the one star that never moves. To find it, trace a line through the two front stars of the Big Dipper's bowl. They'll point straight to Polaris like celestial signposts. Once you've locked onto it, you've got your true north, just as Viking navigators did 1,000 years ago. But Polaris is just the beginning. The sky is a sprawling map, and constellations are its landmarks. Orion, with his unmistakable belt of 3 bright stars, straddles the winter sky like a cosmic hunter. Follow his belt downward, and you'll hit Sirius, the brightest star visible from Earth, which ancient Egyptians linked to the Nile's flooding. In summer, the summer triangle formed by Vega, Deneb, and Altair dominates the heavens, its shape so distinct it's recognizable even in light-polluted cities. These patterns aren't just pretty shapes, they're the same reference points Phoenician traders used to sail the Mediterranean, and that Inca priests relied on to time their solstice ceremonies. While apps like Stellarium or Skyview can overlay constellations on your smartphone screen, there's magic in ditching the tech, at least at first. Try spending 10 minutes outside each night, letting your eyes adjust to the darkness. Notice how Cassiopeia's W shape rotates around Polaris like a celestial clock, or how Scorpius's curved tail marks the southern horizon in July. These observations aren't just exercises, they're how our ancestors internalized the sky's rhythms. Modern research even shows that learning to navigate without GPS sharpens spatial memory and situational awareness, skills as useful in a city as they are in the wilderness. For those craving structure, local astronomy clubs offer a treasure trove of hands-on learning. Many host star parties, where seasoned observers point out Jupiter's moons through telescopes or demonstrate how to measure star angles with just your fist. Fun fact, your outstretched hand spans about 20 degrees, enough to estimate distances between stars. For the truly adventurous, organizations like the Oceanic Society teach celestial navigation courses using sextants, blending ancient techniques with modern safety protocols. It's one thing to read about how Polynesians crossed the Pacific. It's another to stand on a rolling deck, squinting at the horizon while calculating your position from the stars. The beauty of modern stargazing is that it doesn't require perfection. Ancient astronomers made mistakes. Ptolemy's star catalogue had errors, and even the Maya miscalculated some planetary cycles. The goal isn't flawless precision. It's rekindling a connection to the sky that's been dimmed by streetlights and screens. When you spot the Pleiades at dawn, you're seeing the same cluster that told Greek farmers when to plant wheat. When you track the moon's phases, you're joining a tradition that stretches back to lunar calendars carved into mammoth bones 30,000 years ago. So tonight, step outside, let your eyes adjust, find one constellation, then another. The stars haven't forgotten their old routes, and with a little practice, neither will you. Whether you're navigating a forest trail or simply marveling at the vastness overhead, you're part of an unbroken chain of skywatchers who have turned starlight into stories and stories into survival. The tools have changed, but the sky's invitation remains the same. Look up and let the cosmos guide you. Preserving the celestial wisdom of our ancestors isn't just about nostalgia, it's a race against time. In the Marshall Islands, where traditional stick charts once mapped ocean swells using palm fibers and shells, only a handful of elders still remember how to weave these intricate navigational tools. Recognizing the urgency, UNESCO stepped in, adding Carolinian stick chart navigation to its intangible cultural heritage list in 2022. This wasn't just a ceremonial gesture. It unlocked funding for apprenticeship programs where master navigators like Orson Kellen teach teenagers to read wave patterns as their ancestors did. The lessons go beyond wayfinding. They're a lifeline for language, ecology, and communal memory, all encoded in those fragile palm ribs. Across the Pacific in Hawaii, a renaissance is unfolding in classrooms where students learn celestial navigation alongside algebra. The Omalama Hanua voyage of the Hokulea canoe didn't just prove Polynesian wayfinding worked, it sparked a movement. Today, charter schools like Kikula o Nawahiokalaniopau integrate star compasses into science curricula, while night voyages aboard traditional double-hulled canoes turn theory into lived experience. The result, a new generation that can pinpoint their location by the angle of Hokulea Arcturus, rising over the horizon, just as their ancestors did centuries before GPS. Meanwhile, in the hushed conservation labs of the British Museum, a different kind of rescue mission is underway. Using multispectral imaging, researchers are digitally preserving the Dresden Codex, a Maya bark paper manuscript containing Venus tables so precise they're still accurate today. Similar projects are rescuing Babylonian clay tablets from decay, their cuneiform star catalogues now accessible in 3D scans. This isn't merely archiving, it's democratizing knowledge. When the Vatican digitized its secretive collection of medieval astrolabes last year, amateur historians from Lagos to Lima suddenly had access to instruments once locked behind Vatican walls. The stakes transcend cultural preservation. During a military exercise in Scandinavia last winter, GPS jamming left NATO forces disoriented until a Norwegian officer used Viking star techniques to navigate. Indigenous astronomers advising NASA on lunar missions have shared how traditional eclipse predictions account for atmospheric refraction in ways modern models sometimes overlook. Even urban planners are consulting ancient star-aligned city layouts, recognizing their passive solar advantages in an age of climate change. Supporting these efforts doesn't require a degree in astrophysics. Local astronomy clubs worldwide host star mapping nights where volunteers help transcribe historical celestial records into modern databases. Travelers can book voyages on ships like the Hawaiian Mauna Kea, where a portion of ticket sales funds navigation schools. Even stargazing apps now include options to overlay indigenous constellation names alongside Western ones, a small but powerful act of recognition. The stars have guided humanity through ice ages, migrations, and discoveries. They're still here, still whispering their secrets, not just in planetariums or textbooks, but in the living practices of those who never stopped looking up. When a Marshallese teenager learns to steer by swell patterns or a Berlin curator scans a crumbling star map, they're not preserving the past. They're keeping a promise to the future that no matter how advanced our technology becomes, we'll always remember how to find our way home by the light of the cosmos. The forgotten star maps of the ancients aren't relics of a bygone era, they're blueprints of human resilience. Think about it, the Polynesians didn't just cross oceans, they turned the night sky into a living compass, their knowledge so precise that modern sailors still study their techniques today. The Babylonians didn't merely track Venus, they transformed clay tablets into the world's first astronomical databases, their calculations so accurate they rival modern software. These weren't just tools for survival, they were acts of defiance against the unknown, proof that curiosity could chart a path through darkness. What's humbling is how little separated their methods from ours. When a Polynesian navigator memorized the rising points of 200 stars, they were exercising the same spatial reasoning that powers today's GPS algorithms. When a Babylonian scribe predicted an eclipse by spotting patterns in centuries of records, they were using the same principles of data analysis that drive modern AI. The technology has changed, but the human instinct to seek order in the cosmos hasn't. And that's the real gift these star maps offer us, not just knowledge but perspective. In an age where we've outsourced navigation to satellites, their legacy reminds us that true understanding comes from engagement. There's a difference between following a blinking dot on a screen and feeling the tilt of the Southern Cross against your outstretched hand. One tells you where you are, the other tells you where you belong, part of a story written in starlight, stretching back to the first person who ever looked up and wondered. So the next time you step outside on a clear night, try this. Find just one constellation without your phone. Trace the Big Dipper's handle to Polaris, or spot Orion's belt gleaming like a celestial marker. For that moment, you're not just a spectator, you're inheriting a tradition that guided kings, explorers, and visionaries. The stars that lit their way still shine for us, unchanged and unchanging. And as long as we keep looking up, their lessons observe deeply, adapt fearlessly, wonder endlessly will never fade. If this journey through the cosmos resonated with you, let's keep the conversation going. Drop a comment below about your own stargazing experiences, or share which ancient navigator's story amazed you most. Don't forget to like and subscribe. There are more mysteries waiting in the night sky, and we're just getting started. After all, the universe doesn't reveal its secrets to those